My dear friends, in previous class we discussed about the relation connecting Mobius function and the Euler-Torsion function. So we already proved that phi of n equals sigma d divides n. Phi of n equals sigma d divides n mu of d into n by d. So this is the relation connecting between phi and mu, Mobius function and the Euler-Torsion function. Now let us discuss the product formula for Euler-Torsion function. Product formula for Euler-Torsion function. So the result says that for all n greater than or equals 1, we have phi of n equals product p divides n. Phi of n by n equals product p divides n 1 minus 1 by p. This is the product formula for Euler-Torsion function. For n greater than or equals 1, phi of n equals n into product p divides n 1 minus 1 by p. So its proof is, when n equals 1, what happens there? When n equals 1, we already know that phi of 1 equals 1. So when n equals 1, actually what about this product? When n equals 1, we know that phi of 1 equals 1, but when n equals 1, the product is empty. Why? Because there is no primes that divides 1. When n equals 1, the product is empty because there exists no primes which divides 1. So in this case, the product is to be assigned the value 1, thus phi of 1 equals 1. We already know that phi of 1 equals 1, but according to this argument, when n equals 1, there does not exist the prime p that divides 1. So in that case, the product is to be assigned the value 1. So phi of 1 equals 1. Now suppose n greater than 1. The second case, n greater than 1. So that n equals p1 into p2 into etc. into pr, distinct r primes. Then the product can be written as product, come to the right side, product p divides n 1 minus 1 by p equals product I ranges from 1 to r 1 minus 1 by pi. 1 minus 1 by pi. What is product I ranges from 1 to r 1 minus 1 by pi? Can be rewrite as 1 minus sigma 1 by pi or 1 by pi plus sigma 1 by pi pj minus sigma 1 by pi pj pk plus etc. plus whatever the last one minus 1 power r into 1 by p1 etc. pr. Okay. Product I ranges from 1 to r, 1 minus pi can be expressed in this one. It's immediate. Then p1 equals product, what about product I ranges from 1 to 2, 1 minus 1 by pi, that is 1 minus 1 by p1 into 1 minus 1 by p2. Okay. So multiply 1 into 1, 1 minus, the next term is minus of 1 by p1 plus 1 by p2. The last term is minus 1 by, plus 1 by p1 p2. If you expand, then generalize that case. So product I ranges from 1 to r, 1 to r, 1 minus 1 by p is nothing but product p divides n 1 minus 1 by p, also it is expressed in this p. So what is actually sigma 1 by pi pj? Sigma 1 by pi pj means the all products pi pj of distinct prime factors of n taken two at a time. Agree? Sigma 1 by pi pj means it is the all possible products pi pj of distinct prime divisors of n taken two at a time. What is sigma 1 by pi pj pk? Sigma 1 by pi pj pk means it is the possible products of pi pj pk of the distinct primes pn. It is the possible products pi pj pk of distinct prime factors of n taken 3 at a time, and so on. Thus, finally product p divides n 1 minus 1 by p is 1 minus sigma 1 by pi plus etc. plus minus 1 power r 1 by p1 etc. pr. Now, each term on right side is the form plus or minus 1 by d, plus or minus 1 by d, where d is a divisor of n, which is either 1 or product of distinct primes. Each term on right side is plus or minus 1 by d, where d be the divisor of n, which is either 1 or product of distinct primes. Now come to this sign, minus 1, plus 1, minus 1, etc. So this plus or minus 1, what is actually this plus or minus 1? Plus or minus 1 is actually mu of d. Why? We all already know that. What is mu of n? Mu of n equals minus 1 power k when n equals p1 etc. p1 power a1 etc. pr power a. So minus 1 power k. Okay. So this plus or minus 1 is actually mu of d, and mu of d or mu of n, mu of d equals 0 whenever d is a square factor. So clearly this plus or minus 1 then is exactly this mu of d. Plus or minus 1 means the numerator, that is exactly this mu of d. So mu of 1 is this sign, plus or minus 1 is exactly mu of d. Okay. Therefore, from this argument we have when p divides n, product p divides n, 1 minus 1 by p equals sigma d divides n. What about the plus or minus 1? Plus or minus 1 is mu of d, and each of this product is 1 by d, so it is mu of d by d. Okay. So product p divides n 1 minus 1 by p is sigma d divides n mu of d by d. That can be rewrite as n into sigma d divides n mu of d by d into sigma d divides n mu of 1 by n into, not n, 1 by n into sigma d divides n mu of d by d into n. You can introduce n and 1 by n simultaneously. So that can be rearranged as it is 1 by n into sigma d divides n mu of d into n by d. Mu of d into n by d. So what is actually this one? Sigma d divides n mu of d into n by d. Sigma d divides n mu of d into n by d is nothing but phi of n. So it is n into phi of n. That means phi of n equals 1 as phi of n. So yes, 1 by n into phi of n. So phi of n equals n into product p divides n 1 minus 1. Okay. Here each of the term on right side is plus or minus 1 by d, where d is a divisor of n. Either it is 1 or the distinct prime factors, and the numerator plus or minus 1 is always mu of d, exactly mu of d. Why? Because mu of d equals 0 when d is a divisible by any square factor. So product p divides n 1 minus 1 by p, from this right side, from the sum, can be rewrite as sigma d divides n mu of d by d. 1 plus 1 minus 1 etc. that is mu of d, and each of these terms is 1 by d. So it is, you can introduce n and 1 by n simultaneously. It is 1 by n into sigma d divides n mu of d by d into n. Then that is rearranged as 1 by n into sigma d divides n mu of d into n by d. But sigma d divides n mu of d into n by d is nothing but phi of n. So it is 1 by n into phi of n. So means product p divides n 1 minus 1 by p equals n into, is phi of n by n. That is the requirement. Agree? Okay. Now, let us consider some properties of Euler-Torsion function. Properties of Euler-Torsion function. So come to the properties. Properties of phi of Euler-Torsion function. The first property is phi of p power alpha equals p power alpha minus p power alpha minus 1. This is the first property. Phi of p power alpha equals p power alpha minus p power alpha minus 1. This is immediately followed from our result. We have product formula. Phi of n equals n into product p divides n into product p divides n 1 minus 1 by p. Put n equals p power alpha. So what do you get? Phi of p power alpha equals p power alpha into product p divides p power alpha 1 minus 1 by p. Agree? What is product p divides p power alpha? Yes. So it is nothing but it is p power alpha into 1 minus 1 by p. That equals p power alpha into 1 minus 1 by p means come on. P power alpha into 1 minus 1 by p means it is p power alpha minus p power alpha minus 1. That's image. So the first property is immediately followed from the product formula of Euler-Torsion function. Phi of n is n into product p divides n 1 minus 1 by p. You can replace this n by p power alpha where p is prime. Then we have p power alpha into product p divides p power alpha 1 minus 1 by p. That is nothing but p power alpha into 1 minus 1 by p. Why? If you take p power n equals 9. 9 means 3 square. So it is p power alpha into 9 into the remaining quantities. So you will have p power alpha minus p power alpha minus 1. So the first property is immediate. Agree? Now let us discuss the second property. For any two m and n, phi of mn, second property, phi of mn equals phi of m into phi of n into d by phi of d. This is an important property. For any m and n, phi of mn equals phi of m into phi of n into d by phi of d, where what is d? D is GCD of m and n. So how to prove this one? So here again this is followed from a product formula. What is the product formula? We have phi for n greater than or equals 1, phi of n equals n into product p divides n 1 minus 1 by p. Agree? So what is phi of m? It is again m into product. What is phi of m? M into phi of m is m into product p divides m 1 minus 1 by p. What about phi of mn? Phi of mn equals mn into product p divides mn 1 minus 1 by p. Enough. Okay. Now, each prime divisors of mn is either a prime divisor of m or a prime divisor of n. Come to the conditions. Each prime divisors of mn is either a prime divisor of m or a prime divisor of n. So you consider. Suppose m equals 2, n equals 3. So what is mn? Mn equals 6. Surely 2 be a prime divisor of 6. So this 2 be a divisor of 2, either m. 3 be a divisor of 6, then this 3 divides 3. Okay. So 2 be a prime divisor of 6, then either 2 divides 2 or 3 എന്നാണ് നമുക്ക് പറയേണ്ടത്. So it is 2 divides 2, here 3 divides 6 means 3 divides 3. So clear? If a prime divisor of Mn, if P be a prime divisor of Mn, then either P divides M or P divides Mn. Sorry, P divides N. And those prime divisors which divide both M and N, those prime divisors which divide both M and N will divide GCD of M and N. Okay. Each prime divisors of Mn, that P be a prime divisor of Mn, then either P divides M or P divides N, and those prime divisors which divides both M and N, that should divide the GCD of Mn. So consider another example. If M equals 4, N equals 6, then what about the prime divisors of Mn? What is Mn? Mn equals 24. The prime divisors of Mn are 2, 3, then 2 and 3. 3 be a prime divisor of 24. Okay, 2 be a prime divisor of Mn. Here, 2 divides 4 and 2 divides 6. So 2 divides both the M and N. So therefore 2 divides GCD of 4 and 6. Okay. So if P be a prime divisor of Mn, then it either divides M or it divides P be a prime divisor of M or P be a prime divisor of N, and those prime divisors which divides both M and N will be divide Mn. Therefore, by using that argument, what about phi Mn by Mn? Phi Mn by Mn equals from here it is product P divides Mn 1 minus 1 by P from here. Okay, but that equals it is product P divides M 1 minus 1 by P by M. Sorry, product P divides M 1 minus 1 by P. Why? Because if a prime P divides Mn, either it divides M or it divides N. So it is into product P divides N 1 minus 1 by P all divided by, and those prime divisors which divide both M and N will divide its GCD of M and N, that is product P divides GCD of M and N into 1 minus M and N of 1 minus 1 by P. Here phi of Mn by Mn, by product formula it is product P divides Mn 1 minus 1 by P. Since any prime P divides Mn, then P is Mn, then it's a prime divisor of N or it is a prime divisor of N, and those prime divisor which divide both the M and N also divides your GCD. So phi of Mn by Mn can be rewrite as product P divides M 1 minus 1 by P into product P divides M 1 minus 1 by P by product P divides GCD of M and N 1 minus 1 by P. So what is the right side? That implies this left side equals. What about this one? Product P divides M 1 minus 1 by P is phi of M by M. So it is phi of M by M. What about this one? By definition, it is by the product formula, it is phi of N by N divided by, what is this one? It is phi of D by this D. GCD of Mn is D. So phi of D by D. So that means phi of Mn by Mn equals, again it is phi of M into phi of N by Mn, this Mn into D by phi of D. Phi of D by D means this one. Mn cancelling each other. So finally phi of Mn equals phi of M into phi of Mn into D by phi of D. So that is what we requires. So for any M and N, we have phi of Mn equals phi of M into phi of N into D by phi of D, where D be the greatest common divisor of this M and N. So this proof is done, or that is strictly followed from the product formula. Phi of N equals N into 1 minus 1 by P. Okay. Right.